So before we start, I need to give you all of the identities so you have them ready. I would use a formula sheet, put them all on there. Well, I think I gave you a sheet too, so you can put it probably on there too. So reciprocal identities. Okay, so the first one, sine x is equal to 1 over cosecant x. Cosine x is equal to 1 over secant x. Tangent x is equal to 1 over cotan x. Cosecant x is equal to 1 over sine x. Secant is equal to 1 over cosine. And cotangent is equal to 1 over tan x. No, wait a sec. Okay. Let me give you the quotient identities. Okay, Pythagorean identities. These are really important. You're going to see them a ton. But they all actually come from this original one. So you're going to create 9 of them from this one. So if you subtract cosine, you'll make 1 of them. Or subtract sine, I guess. See what I mean? Subtract sine on both sides, solve for cosine. Or solve for sine and you get the other one. So there's 3 using the original. Now, if you take the original and divide by cosine on every single term, you'll create a new formula, which will be this guy. So if I subtract the 1 over, I get another formula. If I subtract the tangent over, I get another one. Okay. Now, if I divide everything by sine, we get 1 plus cotangent equal to cosecant. Don't do the same crap, just subtract each piece and you'll make 2 more. So here we go. Forgive me if I am exhausted. Subtract the 1. There we go. Do you see where all these formulas came from? Or no? I didn't show the division part. Right? You see, if I divide by cosine, you get sine over cosine, which is tangent. Right? If I divide cosine by cosine, I get 1. Divide 1 by cosine, that's going to be this one, which is secant. That's where this came from. Similarly, you do that here, but with sine, then you just move stuff around. So these will be very important. So make sure you have them handy. I think they're also in that sheet that I gave you, that green sheet. You guys still have it? If not, just make a more formula sheet with these guys. Cofunction identities. So cofunction basically says if you shift it, that looks ugly, it'll become the other function. So sine and cosine are cofunctions of each other. I don't know if we'll need this, but just in case, pi over 2 minus x is going to be cosine x. If you do it with cosine, pi over 2 minus x, that will be sine tangent of pi over 2 minus x will be cotangent and the opposite will be tangent. Try to give you all the properties before we start. Even and odd properties. Sine of negative x is equal to negative sine. So that is considered to be odd. Cosecant is just the reciprocal, so of course it'll be the same. Tangent is also odd, which means if you plug in a negative x, the negative comes out in front. That is a property of being odd. Cotangent, same deal. So almost all of them are odd, except cosine and its reciprocal. So cosine is an even one, which absorbs negatives. And secant is the same deal, so secant. So if you plug in a negative into cosine, it's as if you plugged in a positive. Secant, same thing.
say cosine and secant are even, correct?
Yeah, these are the only even ones. The rest are stupid, man. Odd. I'll give you the. Do you remember the definition of even and odd from college algebra? No. I'll write it on the next page then. You guys cool on this page?
Sir, can you like make it more visible?
Oh shoot, I didn't.
Blur.
I forgot to hit pin. I'm sorry. Thanks. Okay. Any questions on these properties? We're going to use them a bunch in just a bit. So real quick, I'm going to put it up top. Even means this. If you plug in a negative into a function, and it's the same as a positive version, that's even. If you have an odd function and you plug in a negative, and it swaps all your signs of the function, becomes the opposite, then that is odd. It doesn't have to be one or the other. It could be neither. So that was back from college algebra stuff. I think back there they asked you to show if it's even or odd a long time ago. Let me open the homework up. You guys see any snow out there? Saw some flurries. I don't know if it's stopped. Let's look through this real quick. Did you guys just drive over here? Or no? Did you see any snow? Any snow coming down? There was some earlier today, but I don't know if it was still happening. Around here, actually. Let's see. So first few are just basic formulas. Let's start with problem 9, I guess. So use fundamental identities to simplify the expression. So all I want you to do is simplify. We're not solving for anything particular. So you have to look at your properties and change them into different things. So tangent as a quotient, what is it? Right, look at the quotient properties. What can you change tangent into? Yeah, right. You got sine over cosine for tangent. and cotangent is sine over or cosine over sine. So they're actually opposites, right? So if you were to multiply them, something special should happen. If we change both, this is with the, call it quotient or ratio? Quotient. So if you multiply that out, what's going to happen? Yeah, it's going to be 1, isn't it? If you don't see it, let's multiply it together. Sine times cosine, cosine times sine. What is secant as a reciprocal? So go back to your properties. Secant is equal to 1 over cosine, right? So change it. This becomes 1 over cosine. Reciprocal property. That's what we use. So these are going to cancel, leaving me with 1 over cosine. When you have 1 over cosine, it's gonna flip, right? Giving us just 1 over 1, that's this piece, times cosine theta over 1. So this guy flips over and multiplies by the 1 on top. So that's the simplified version. So that's what they're going to want you to do in the homework, the first few problems. Use something that looks weird and use your properties to break it down and cancel stuff and get it to something simple. And at this point, there's nothing else we can do, right? Do you see any property we could use that would make it more simple? All these steps make sense? Let me know. Yeah, so they just wanted to change it to cosine. So number 10, same type of deal. Let's do 10. So 10 squared minus 10 squared times sine squared. So simplify this. There's no right way to do this, just try something. First thing I see is that they both terms have a tangent, right? So try factoring a tangent, see what happens. So if I pull out tangent from both of these, do you agree that we have 1 minus sine squared left? Is that clear? What is 1 minus sine squared? see how that's equal to cosine squared, right? So you have to substitute it. So use this identity here to change it to cosine. So that's a little more simple looking than 1 minus sine squared. So this becomes and we use the Pythagorean identity. Can we go any further? Do you see something that we could use? You see how there's no real like obvious path. You just have to think about it. Or look at the identities and figure out, okay, what can I use to cancel something or convert something? This looks better than the original. When you see a tangent, you should consider changing it to a quotient, a ratio. So what is tangent as a ratio? That's true, but yeah, let's use that one though. Do you see why? So we change tangent to sine over cosine, so we can cancel this cosine by multiplying. So now we went and changed the original to just sine. Does that make sense? You see how we're not solving for anything, right? We're just practicing with our properties. We're using them to simplify a problem.
I don't understand the first step. Like how you can factor it. I don't understand what you did there.
So they both have a tangent squared in common, right? This is a single term and another term. Picture it as if it was an x squared minus x squared times tangent or times sine. You would pull out that x, right? Like for example, let's say we had this going on. You can factor x squared from both, right? And you would get Does that make sense? You see what I'm saying, or is that weird? Right, they both had it in common. Like if this was a 2x squared, this would be a 2. So we're just pulling a common factor out. Once we did that, this became a 1. It's like it's as if you divided it by tan squared. So these tangents are gone.
Are they found? Tangent squared sine squared x. You see like how
Yeah, this is a times. Okay, let me give you one more example because I feel like it's bugging you. Like back in the day, if you had something like this, what do they have in common?
I understand this, like, because you would like parentheses that pull the x aside, and then it'd be like x plus 2, right? It'd be like factoring that out.
Yeah, you see that this is the same. This is like my x.
So, but instead of leaving nothing there, it'd be like leaving you'd leave a 1 as a placeholder then? Is that what that is then?
Yeah, like you leave the 2 there, like you said earlier. So you leave a 1 there because if this was a single x, you would leave a 1 behind. Right? If you factored it, what would you get? right? I mean, you factored earlier. There was a 2 there, now there isn't. So you pull out an x from both. You have to leave something behind.
Okay, yeah.
So when you distribute it, you see how we're going to end up with this. If you distribute this back in, you would get back to here, right, to the beginning. Right, tangent squared times 1 is tangent squared. Tangent squared times sine is this nonsense. Does that make more sense, or is that okay? Okay. Any other questions on this? You see how this became cosine and why it canceled? Okay. Let me know. These are a little hard. I hope you ask questions if they don't make sense. Let's do one more similar to this. You guys cool on this page? I think this is, the next one's 11. Yeah, let's do this one. It's very similar. So sine squared, secant squared, minus sine squared. So start in a similar way, right? You see how they both have sine squared in common. So factor the sine squared. So I'll be left with secant squared x minus the 1. So at this point, you need to recognize, what is this? Secant squared minus 1. You have to check your identities. Unless you memorize all 60 like I had to. What is secant squared minus 1?
Tangent squared of x.
Yeah, tangent squared. Okay. Can we simplify any further? I don't think so. Maybe. It's as good as it gets. Because tangent is sine over cosine, so it's not going to cancel anything. So yeah, that's as pretty as it gets. We use Pythagorean. Any questions on 3 or 2 or 3? Yeah, one more time. So first step, right? You see they both have sine in common. So we factor sine from both. When you factor it, you see that this whole thing becomes secant squared minus 1. That's clear? So this right here, back in the first page. Our first page, we said that secant squared minus 1 is tangent squared. So you change it. That's why we get that. Well, that's how we're doing. We're using all the properties that we wrote down. And we're trying to simplify the question. In a moment, I think, well, maybe next section, we're going to try to prove things, which is the one that's a little harder. Any other questions on 3? Okay, so here's another one. You see a bunch of cosine squares, right? I would make an extra step here. Maybe this will give you a hint as what the heck to do. You agree that squared is a fourth, right? I can rewrite the fourth. You see a bunch of squares, that should give you a hint. Use a substitution for cosine squared. What is cosine squared equal to? That's the first one, second one on the left, I think. And they're Pythagorean.
1 minus sine squared.
So I can't tell you how to do this. You just have to try something and see if things cancel and simplify. That's what you need to do. So when I saw this, I thought, well, there's a square and a square here. Maybe if I use this, something will happen. I don't know if it's gonna work. So when you're doing things, you start and the problem starts to turn into something crazy. If I took a bad path, just try something different. Start over. Okay. After a while, you start to see patterns, and you start to think, okay, maybe I should try this. When I see a square, think of Pythagorean. When I see tangent, think of quotient. When I see like something strange, maybe try a reciprocal. Okay. So you just got to try something. So here we go. I'm going to replace every cosine square with this. And I'm going to hope that does something. Does that part make sense? So square the 1 minus sine squared and multiply the other one by -2. See what happens. So this becomes 2 times -2 times 1 is -2. -2 times negative sine is 2 plus 2 sine squared x. If you square this guy, you're going to get 1 minus 2 sine squared plus sine to the 4th. Because you have to FOIL this, right? It's 2 of them. So multiply it twice. Yeah, it's cool from here to here. All right. Do you see that a bunch of stuff is going to cancel? So you have a 1 plus 1 minus 2. That's 0, right? So 1 plus 1 minus 2 plus 2 sine minus 2 sine. All that garbage is going to cancel. So it did simplify, thank goodness, because I don't want to redo this a different way. So be careful with the algebra and use your identities. Okay, that's all you're doing here. Is there any questions on 4? What do you think? Is it straightforward? Is it weird? Okay, so first gotta figure out what the heck are we doing, right? What are we trying to do? It's the first thing. We're trying to simplify the question into something smaller. So right now it looks complicated. Like, see how the original up here was all this garbage?
Yeah.
We got it down a little smaller. Great. And the other one, we had all this garbage. We got it down to a single cosine. So that's simplified. That's what we're doing. We're using all the properties on that first page to try to break it all down. Kind of like Tetris, right? Trying to get all the pieces in there, get rid of the lines. That's what we're doing. This is like a really strange game. This is like annoying Sudoku. That's what we're doing here. It's not. We're not solving for anything. We are playing.
Can I go farther down? Can sine 4x be broken down farther from where it is now?
It could, but we need some properties we haven't talked about yet. You could do double angles. But this will be enough for the homework. The shitty part is that these are difficult to do on the homework because the computer doesn't really understand pieces by piece. So on the exam, you need to show me something like this, right? On the homework, it's like, oh, you're just gonna put in that last piece, and they don't really care about what happened before. But if you try something and you get mostly there, then you'll get a bunch of points from me because it's partial credit. But if all you put is that final thing, you're not gonna get anything. So make sure you break it down and make a good attempt. Just try. Try to simplify. So what we did here, one more time. I noticed it was a square. And I also noticed that a fourth is a squared square. So I said, okay, well, let's break it down. And then substitute this cosine squared with this. Whenever I see squares, I think about the Pythagorean identities. So I chose this one on purpose. I plugged it in for this square. Plug this in for this square. After that, we just did algebra. We multiplied the -2. We squared this, got those 3 terms. Everything canceled, leaving me with just this. That's all we did. Any questions? Does that make sense or make more sense? All right, let's do some more Sudoku here.
Are they all gonna look like this? Like what it's presenting to us for us to simplify? Like however many questions it was, I know you scrolled through it. It's not gonna be like 15 or whatever. They're like this, right? Like simplify. Are they all gonna be?
They could be. They're all very different, honestly. You'll see some reoccurring patterns, but a lot of it is just try something.
I mean, like in the presentation of it, is it just gonna say like simplify this, or is there gonna be like how some of the other problems over it has like this, like a multiple factor, whatever it is, like a word problem or however it be?
There shouldn't be any word problems in these 2 sections. 7.1 and 7.2, we're not solving for anything, so there is no word problem.
Okay.
For example, to factor the expression, simplify, all of it is simplify. Nothing else.
Okay, cool. I was just curious. Sorry.
Yeah, there's nothing weird at the end like
Like when it says like perform the addition, will we be able to? Is that something that we've kind of already done?
that's form addition of two fractions means add the fractions. So you're gonna have to do LCD. So yeah, that is something you've done before, but it's using trig functions so that it looks uglier. But we can do that in a little bit if you want. Let's see here. Let's do the 14th. This one looks different. 13. Problem 13. Simplify. So 210 of negative x times cosine. So what do you think we should use? Which one? Yeah, quotient would be good. But first, we should probably deal with that negative x. When you see a negative x inside, you should think even and odd properties. So there's some subtle hints on what to do. So is tangent is odd, right? We said. Oh yeah. Thanks. So if there's a negative x or negative something inside, you can pull the negative out. So this becomes negative 210 cosine. So now let's do the quotient. Quotient says that tangent is what? Sine over cosine. Do you see what will happen now? What happens to the cosines? Gonna cancel, right? So we get negative 2 sine. That's it. This is a simplified. So from here to here, we use the even and odd properties. Here we did quotient. And that was it. We did some algebra. Nothing else.
It's really interesting back to last semester, started the course and also like
Yeah, I think the hardest part is trying to decide how to start. Like, because once it begins, it kind of starts to undo itself. But like finding out like where's that spot, I guess, that technique. That takes practice. So make sure you practice. Any questions on 5? So far you're starting to see a pattern, right? If you see a square, think Pythagorean. If you see tangent or cotan, think ratio quotient. Hope things cancel. Here's another technique. It's cool on this page. Should have bought a monster, man. Dying over here. Example 6.
they don't have any, I think we should.
Yeah, that's what I'm saying. I should have grabbed one before class. Should've. Let's do this. 16. Okay. This does not have a square. Otherwise, it'd be too easy. So when you look at this, what do you want to try? Because you need to get used to figuring out what's the first step.
See what you said, it was too easy right away. No.
Yeah. Even if I put that square on there, let's make it a little harder. You see the cosine, correct? So that should be something you should want to try. Try the Pythagorean. So which one? That one, I wouldn't use it unless you see a pi over 2 in there, then try it. But if there's none in there, it's probably not going to help. Maybe. Sin squared equal to 1 minus sine squared. So now when you get there, you notice that looks kind of like the bottom, right? Almost. But it's not. So what can you do with that numerator?
Side effects come out, like you factor out.
This can be factored, but in a specific type of way. Do you remember the difference of squares? If you have two squares being subtracted, do you remember how it always factored this way? That was a while ago, so I think you first see that in like middle school, maybe. That was a long time ago. But it does keep coming up. College algebra, and pretty much most math classes, you'll see it over and over again. So this 1, if I write it as a square, it's still a 1, correct? 1 squared is 1. So what I want you to see is that this is a difference of squares. Is that clear? You see how these are the same? Or no?
Where's the square of the 1 coming from?
I put it there because there's no difference, right? If you square it, it's the same as if you didn't. It's 1 squared is 1.
Okay, well, that's what I figured.
So you can rewrite it just for emphasis. So if you rewrite it, it becomes more obvious that you can apply this formula because you have something squared minus something else squared. But yeah, the square is not really there, but you can square it if you want. So you see how we factored. This is my a and b. A squared minus b squared. A minus b, a plus b. A minus b, a plus b. Is that obvious? So then, what do you see? What happens?
One minus sine x.
Yeah, they're going to cancel. So once you factor it, it simplifies, doesn't it? That's it. There's nothing else. Any questions on 6? It's okay. All right, let's do the one you were asking about, William. This guy, right? You said. All right. Do it on the next page. You guys cool on this page? Let me write this down. I'm going to shorten this up, add and simplify. That's really all they're asking for. Example number 7. So the answer is supposed to be 2 secant. I don't know how that's going to happen, but let's try stuff. So how do you add fractions? Like if you had a half plus a third, what would you do? Yeah. So on the common denominator would be 2 times 3 because they are prime. These are also prime. So whenever they're prime, the common denominator will always be the product of the 2 denominators. You can't factor this, right? Do you see anything in common with 1 plus sign? If you can't factor, then it is prime. Cosine is a single term. You can't factor anything out. So it's prime. So since they are prime, the LCD will be this product. Does that make sense? Just like the other one would be 2 times 3. 6 would be the LCD. This is the LCD. Does that make sense? So this needs a cosine on the bottom. This needs a 1 plus sign. So introduce that missing piece. And once you do, you can add them together. So here we go. Do you see what we are doing? Now we're introducing the missing factor to get this common denominator. Is this step okay? So cosine times cosine. On the bottom, you cool if I write the word LCD? Because that's what this is, right? Down here. They both have it now. For now, we'll put it back in a second. Now that they have the same LCD, you can add the top part. So that'll be cosine squared plus this nonsense over LCD. Okay. So FOIL the 1 plus sine. And I'm going to put back the actual term. We might need it. I don't know. Saved us some writing though. So FOIL this guy, and you're going to get these three terms. You guys see how that happened? I haven't been showing the FOILs, but do you agree that 1 plus sine times 1 plus sine, right? 1 times 1, 1 times sine. Oops, son of a, smeared it. 1 plus sine. So distribute. That'll give us sine. No, the one first. Don't be weird. 1 times 1, 1 times sine. Sine times 1. Sine times sine. So that's where this is coming from. I use the formula to skip this because it's annoying. But if you don't remember the formula, you can always multiply it out if you want to. I'm not going to stop you from doing more work. It's up to you. I recommend the formula. The formula that I use is this guy. Because math people are all about working less, not more. Here's the formula. If you have two things being squared, just plug those two things there. That's where I got this from here. That makes sense? So that 2 is built in. The 1 was sine, so 1 times sine is sine. B is sine, so sine squared. Cosine squared plus sine squared. What does that equal to in your formulas? And that's the first one we wrote in Pythagorean. Right. Or sine plus cosine. It's going to be 1, right? When you add them together, you get a 1. So let's put them right next to each other so it's obvious. You don't have to, but this right here is a 1. So we get 1 plus 1 plus 2. Which gets me 2 plus 2 sine. over 1 plus sine cosine. What would you try next? Simplify it a little bit, right? Just now. And you see that they both have a 2, right? So try factoring. You have to figure out what to try on your own. Do you see now what's going to cancel?
Where does the other 2 go?
Factor the 2 from both terms. Right? Maybe
I
just
see. Yeah.
so then cancel. So now we have 2 over cosine. What is 1 over cosine on your identities? No, it's one of the reciprocal properties. 1 over cosine is secant, right? So if we have 2 over cosine, what do you think that's going to be? 2 secant, which is what the answer was, right? That's what they had. Now, if you're wondering why is that, you could technically write it this way. 2 over cosine is the same as 2 times 1 over cosine. So this guy right there is secant. Okay, any of these steps that I may have lost you at, or you got spaced out or something. This happens to me all the time. The ending okay? Or the middle? Beginning? Okay. So have those formulas handy when you're doing the homework, and try to show every step along the way. Because if you lose your way, at least you have something for me to grade. Get some ton of partial credit just for trying something. Even if you get lost. Yeah, I think that's it for this section. So now we're back on schedule. So we did 7-1. Today is the 23rd. So what I would like you to do is practice 7-1, get comfortable with those properties, because on 7-2, we're going to use those properties to prove stuff. So that's a little harder than what we just did. So we're going to end up, basically they're going to tell you the answer. They're going to say, I don't know. They're going to say something like, they'll give you this, and they'll say, okay, this is equal to 2 secant, prove it. So you got to pick, either start here and go this way, or start here and figure out how to get this 2 secant. Or they'll give you something completely different. Like, I don't know. Maybe they'll give you something like this, get to there. So that's what we're gonna be doing on Monday. So try to catch up on the homework, that way it's not as intimidating. Okay. You guys have any questions about anything? Have any issues with the test stuff?
Any like a middle school math class I can sit in on it? Because I missed probably all of those, it seems like.
I mean, it does fade if you don't use it, but you should have seen it in college algebra a little bit. You know, like all the factoring stuff.
Yeah, I was looking through, even though it was only like 6 months ago that I took the class, as I was flipping through my notes, yeah, I have no idea. You know, since now it's become my scratch like sheet or whatever, like a little journal.
Yeah.
And I have no idea. Like 4 months ago, I walked out there with like a 97 in college algebra. No idea what's going on there now.
So you look back and it makes no sense.
Yeah, so I'm gonna have to sit in that math lab a lot in the next 2 weeks.
No, I mean, yeah, that's what it's about. It's all about practice, and so it makes sense. If you don't practice it, you're gonna have a hard time.
Is there a way to fill in the gaps you think of? Like, you know, because like I said, there are giant holes in my skills when it comes to math. Like, is there a way for me to like, 'cause, like for example, the algebra stuff I feel very comfortable with, but then there's some basic things like reciprocals, like multiplying fractions, whatever. Whenever you flip something upside down, you're like, yeah, I just flip this. You lose me right away every time. It doesn't matter. It's
I would just find that topic and just watch a bunch of videos on it. That's what I would do. Like if I forget something, like something I never use, you know, I'll watch a video on it, practice it, and like, okay, I remember that. Then I'll move on. So
like
identify
Sylvan's not returning my calls.
identify the holes, and then find that topic. It shouldn't be too hard. Or write down a bunch of practice problems and do them yourself, because watching it might make sense, right? But when you start doing it yourself, you're gonna realize, okay, I don't know how to do this part, I'm missing more things. So start trying to work through it so you can identify the issues. Because like you can watch Michael Jordan play all day long, but until you start playing, you don't know what you don't know. I guess we'll stop here. If you guys have questions or homework problems, let me know. Otherwise, I'm just gonna sit here till 9.